All right, this is recording 2 for topic 10, one sample t-tests. And we just went through some examples. We talked about SPSS output, how to calculate it, and so forth. So now let's look at an example in the published literature. Okay, get there. Here we go. Okay, health-related quality of life among substance abusers in residential drug abuse treatment. All right, so the present research compared 303 substance abusers in a long-term residential therapeutic community treatment in New York with a general non-institutionalized adult sample from New York, right? Whose data were collected between 2002 and 2006 during the yearly administrations of the behavioral risk factor surveillance system, right? A state-based system of health surveys gathering data from upwards of 350,000 adults per year across all 50 states. One sample t-test found that the in-treatment substance abusers reported significantly more physically and mentally unhealthy days over the past 30 days, as well as significantly more inactive days over the past 30 days due to illness. So basically what they're doing is they're comparing the substance abusers to everybody else, right? So we have substance, let me get, okay, so we can see these, right? We can see the mean and standard deviation for unhealthy days, physical, mental, and inactive right here. Oops, sorry about that. Let me go back down. Right here are their standard deviations, and this is the general sample. So everybody else you're comparing them to. We have the degrees of freedom, right? So this is going to be n-1, and then the t value. Okay, this is t obtained or t observed, right? So can you perform the calculations using the table below? Okay, so remember degrees of freedom is n-1, so n must be 301. And then if we plug everything in, we should get the same value. And as you can see, we do. And look at those annotations, they're not clear. Okay, there we go. All right, so what does this mean? The asterisk, this means that P is less than 0.001. It should not have that 0 in front of it. See, even in published research, they do those mistakes, right? Okay. Interpret for physical, substance users more physically unhealthy than general population. Okay. Mental, substance users had more mentally unhealthy days than the general population. And substance users were less active than the general population in the past 30 days, right? So that's your plain English. Okay. All right. So what about testing the correlation coefficient? So as you know, Pearson-Zahr describes the relationship in a sample. We want to know if this applies to the population, right? We are interested in populations, not samples. So we're going to use inferential statistics. So the significance of that correlation coefficient determines whether we can assume our sample represents the distribution of the alternate or the null hypothesis, right? So our parameter is rho, remember, degrees of freedom for correlations is n-2, right? Because that's pairs of scores, right? So remember, the null hypothesis is that there's no relationship in the population. And we want to find that our data has a correlation that is so different from 0 that it will be very unlikely if that obtained from the null population of no relationship, right? Okay. So our assumptions for Pearson-Zahr is that we have a random sample of X and Y scores, and each variable is an interval or ratio variable, right? It has to be continuous variable scale in SPSS. The X and Y scores are each from a normal distribution, plus they represent a bivariate normal distribution. That means that the distribution of the correlation between the scores is also normal. The null is that there's 0 correlation. Okay, so here's our hypotheses, right? The null is that rho equals 0. The alternative is rho is not equal to 0. Now, you can also do, that's for a two-tailed test. For a one-tailed test, if we're hypothesizing a positive correlation, then we start out with the alternative, rho greater than 0, right? R is greater than 0 or positive. And the null is the opposite with an equal sign. So rho less than or equal to 0. Remember, null hypotheses always have an equal sign in them somewhere. And for a negative correlation, it's the opposite. For example, I hypothesize that people with stronger religious faith will be more self-forgiving. This is a one-tailed test because as religious faith goes up, we expect self-forgiving to go up as well. Okay, so the alternative is rho greater than 0, and the null is rho less than or equal to 0. We set our criterion, it should be criterion, alpha 0.05. Our decision rule is reject the null if p less than 0.05. So we run a correlation analysis. Now, this is from Jamovi, this output. We have to remember that in SPSS, it doesn't say p-value, it says sig, right? Something like that, sig for significant, right? But it's the exact same thing, okay? Okay, and we find that Pearson's are of negative 0.044 with a p-value of 0.438, right? Decision, well, 0.438 is clearly larger than 0.05, so we fail to reject the null hypothesis and conclude that there is no evidence that religious faith is related to forgiveness, okay? People's religious faith was not related to their self-forgiveness in this sample. Let's run through another example. So remember aggression and moral identity? I'm sure you do. You're probably sick of it, right? So the experimental hypothesis is people with a greater sense of moral identity will be less aggressive. This is a one-tailed test, but of a negative correlation. So the alternative hypothesis is rho less than 0, and the null is rho greater or equal to 0. The criterion is alpha 0.05. The decision rule, reject the null if p less than 0.05. So here we have the output we've seen very frequently. We have a correlation of negative 0.298, right? And here you can see the output from SPSS, right? We can actually see that it says sig, that's for significance, for a two-tailed test. Remember, you can set SPSS to do a two-tail, one-tail test, less than 0.001. This means that the likelihood of obtaining this result of Pearson correlation of negative 0.30, if these data came from a null distribution where rho equals 0, is less than 0.001. So it's very unlikely. Our decision is reject the null hypothesis. Greater moral identity is related to less aggression. In plain English, people with a stronger sense of morality are less aggressive. Right? There's our values. Okay. That's it. If you have any questions, email me, and remember to look at the SPSS tutorials for the one sample t-tests.